We have in lesson 1, work and power. We are going to cover some key concepts like what must happen for work to be done and how does doing work on an object change its energy. For example, here, how can we use the energy to do work? How can we use the energy, the transferring of energy, to apply a force on an object to move it? What must happen for work to be done? What do we have to do? And we are going to call it work. And how are work and power related to each other? What's the relation between them? Before we start the lesson, we have to know that we have some key words or new vocab, which are work and power. First, what's work? If I'm asking you to push or kick something on the ground, now you will apply a force, use energy, and apply a force to move it. So you will use your energy, apply a force on the object, and you will make the object move. The three things now that are happening are called work. So work is a transfer of energy that occurs when a force makes an object move. If you are applying a force and making the object move or change its place or change its possession, now it's called work. When work is done, it's done when you move the object, as we said. But also you have to move the object in the direction of the applied force. If you are pushing the pole or something on the ground towards right side and the object will move right, it means that there's work done here. But if you are applying a force and the object will not move, so no work done. Or if you are applying a force and the direction of the movement, the direction of the force are not the same, so no work is done here. So you have to make sure when is work done, if you are moving the object in the same direction as the force, and if the object moves. But if the object's not moving or it's moving in a different direction than the direction of the applied force, so there is no work done here. For example here, no work is done. Why? Because I'm applying a force, but this force is not making any change. It's not making the object move. I'm pushing a wall. I'm applying a force, yes, but am I moving the object? No, so there's no work done here. So work is important, yes, because it's related to the energy. It identifies the energy that we use, and also it is described by the forces and distance to make the object move. As we said in the previous slide, force that doesn't make an object move does no work. How can we calculate the work? We said that we have different factors that we are going to describe if I'm describing the work or the definition or the word work. Work is the force done to move an object. So I'm going to multiply the force applied to the object by the distance the object is moved by that force. We know force is, or it has unit, it's called newtons, according to the scientists that discovered it before. Multiplies by distance in meters, now we will get the work in joules. So W equal F by D. The product of force and distance has the unit Newton dot meter, and Newton dot meter, it's also known as joules, which is the unit for work. For example here, solve this one. A student pushed a desk 2 meters across the floor using a constant force of 25 Newton. How much work does the student do on the desk? First, I have to write what I know. What you know? The force and the distance. Force, 25 Newton, and the distance, 2 meters. Then you're going to write what do you need to find. I need to find work, which is W. Now I'm going to use the formula, which is F by D. Then I will substitute or do the substitution here. Work equal 25 by 2, which is 50 watt. I have to write the unit, which is 50 joules. So from this one, we are applying the formula that we have about work, which is force by distance. I have to multiply them to get the work. But if I'm asking you to calculate the force, what you are going to do? I'm going to write a sample here, triangle, to explain or show us what are or how can we get the force or use it to identify the different things or the different factors here. I'm going to write here at the top work, which is W, and here I'm going to write force and distance. And we know that if they are next to each other, it means multiplying. If they are over each other, it means divide. So if I need to get now the work, I will say W equal F by D. But if I'm getting the force now, I will say it equals W divided by D. Let me write it for you. And if I need to get the distance, I divide work by F. So these are the three formulas that we have to know to calculate or to solve any mathematical equations or any mathematical problem about work, force, or distance. We have the main one, force or work equal force by D. How can we get the force? By dividing work by D by distance. And how can we get the distance? By dividing work by force. Okay. Now we have another one. Calculate the force done to move an object for 5 meters. So I have the distance here, knowing that work done here is 20 joules. I have force and I have work. Work and distance. Can we get the force? Yes, we are going to get the force by dividing work by distance, which means 20 by 5 equal 4 newtons. So now we can get the force by dividing work over distance. This is work, and how can we know? And how can we know if it's work or no, or when the work is done? By finding the main factors, which is applying force and the distance that the object moved by this force.